Happy morning, Platinum students. So there's two fish in a tank, and while I'm telling you this joke, please get out your textbook to go to page 572. But there's two fish in a tank. One fish turns to the other one and says, I'll man the guns, you drive. There it is. Alright. Today should be a review of some geometry that you may have learned last year. I'm not sure, some of it might be some new things, but I think this is kind of a review. We're looking at triangles and angles in general. So the first thing we're going to look at are some triangles, looking for missing angles, and then we're going to look at some angles, and finally triangles again. So kind of a triangle sandwich. So please make sure you're on page 572, follow along while I'm on the board. But here's the basics. A triangle, all of the angles inside of our triangle add up to 180 degrees. That's what this is showing you here. So if we have angles X, Y, and Z, they all add up to 180 degrees. They should not add up to 179 or 181. That would not be a triangle. That would be some other funky shape that I really don't know what it would be. That would be cool. Maybe something you could study. I'm not sure. But just some other terminology that you will hear me use is we have angle, and that is looking at this right here. What is the degree measurement of an angle of a triangle? We also have side, and this points to the whole side line of a triangle. So sometimes you'll see that mark. We'll get to that. And then last we have a vertex, which is the point at the edge of an angle. So angle, vertex, and side. All right, let's go to the next page. So what do we do if we have a missing angle? So here we have the missing angle P. We know that our angle is labeled P, and we need to find X. So this is where we just set up a normal algebra problem. We take what we know and we try to solve what we don't know. So we have 89 and we have plus 54 plus X equals 180. So we add together 89 and 54. That is going to be, sorry, I gotta use a calculator, 143 plus X equals 180. And we gotta get X all alone, so we subtract 143. Again, I want to see this work in your books. I'm telling you this now because I want to see it. X equals 37 degrees. Make sure you get your degrees symbol in there. But this is exactly the work that I want to see in your book. Again, I know you can use your calculators, but I really want to see that work on paper. Okay. Now, what if they don't give you a visual and they just give you some words? This is kind of the words, another example out of your book, where it says triangle DEF. Angle D equals 62, angle F equals 39, but what does angle E equal? So if you're like me, it can help to draw a triangle just to kind of plug numbers in. So I've got, for example, let's say this is 62, this is 39, and this is X. So sometimes we just need that visual aid. So again, we set it up the same way, 62 plus 39 plus X equals 180. And after you do all the work, X will equal 79. 79 what? Not 70. 79 degrees. That's right. 79 degrees. Okay, let me know if you got questions about this, about finding the missing angle, but we're going to move on. Alright, next thing. This is probably new. Ratios to find angle measures. Now, it's going to be kind of confusing at first, but hopefully I can clear that up. So here's what the problem looks like. It says triangle ABC ratio is 1 to 3 to 8. Now, what is the angle? It's asking us what are the measures of the angles. So since we know that this is in a ratio, what we do is we set up a different algebraic problem. What we do is we simply attach x to each number. So we have x. X goes with 1x. Then we have 3x. That goes with the 3. And then finally we've got 8x, which goes with the 8. So we set up our algebraic problem like that. Then we got to solve for x. So now our next step is to add our like terms. So we have x plus 3x is 4x, plus 8x is 12x, equals 180. Divide both sides by 12. X equals 15. Okay, but we're not done there. It's asked us what are the angles, angles for A, B, and C. What does each angle equal? So now we have to plug in 15 for each angle. So for each variable. So I'm going to say 15 for x. So that's going again right here. And so I'm going to say A equals 15 degrees. Next thing would be B. So now I do 15 for 3. So 3 times 15 is 45 degrees. And then angle C, I should draw my angle signs. Angle C is going to be 15 times 8. 8 times 15, 120 degrees. All right? So what we did is we created an algebraic problem using our ratios. Whatever ratio they give you, you just turn in these numbers and make them coefficients of x. Remember, coefficient is the number in front of the variable. So our 1, whenever we say 1x, we just put an x. 3, 3x. 8, 8x. And it always equals 180. So that's kind of new, but I hope you get the grasp of it. Again, watch the video again or ask for help if you need to. Moving on, though. Next thing, just a quick review of angles. Remember, if our angles are acute, which means that they are, the angle is less than 90 degrees. That means they're acute. If they're right, that means that they're equal to 90 degrees. And obtuse means that they are greater than 90 degrees. And then last we have a straight angle, which is equal to 180 degrees if it's flat out. Okay, quick review. Good. Next thing, when we take that information, we can also apply it to triangles. So there are different names of triangles. We have acute, obtuse, and right. And all depends on what angles make up the triangle. So an acute triangle has all acute angles. So if we were to measure all these different angles, they're all acute. They're all less than 90 degrees. Obtuse, one angle is greater than 90 degrees. So if there is one angle that's greater than 90, it is an obtuse triangle. And lastly, a right triangle, if one angle is right, then the whole thing would be right triangle. So that's what I tried to write right here. Okay, and the way that that's going to work is you're going to be asked to define or identify, name different triangles. So that's going to be the first thing. You're first going to say it's an acute, it's an obtuse, something, and the second criteria is this one. Here's some new words. So it could be acute scalene. Scalene means no congruent sides. Now the definition of congruent means that they're not the same, that each side has a different length, or if you have all different angles, then that means that you do not have a congruent side. Again, if you want to check, this is now we're on page 574. I'll write that right here. Page 574, you'll see this list, and it gives you an example of scalene of they're all different angles. So if you look at the acute angle at the very top, that would be acute scalene, because there aren't any sides that are the same angles. So no congruent sides. Second, isosceles. This means that we have two congruent sides. So the way we get two congruent sides would mean that these angles are the same. So they would both equal 40 degrees, for example, or something probably bigger than 40 degrees. But they have two similar sides. So this triangle, would be acute isosceles, because all the angles are less than 90 degrees, but we have two congruent sides, so it's acute isosceles. Last thing, we have an equilateral triangle. That means that all sides are congruent, all of them equal. That means all of these angles are the same. So again, what do you think? Are they all less than 90 degrees? So this one would be acute equilateral. All right. Let me just make up something here. What if I had a triangle like this, and let's say that this one is 120 degrees, and this angle is, what do I want to do, 30 degrees, and this angle is also 30 degrees. What would this be? Remember, our first thing is based on the angles. Base it first on an angle. So here we have an obtuse angle. So this is going to be obtuse. And then next thing, we look at our sides. Based on our angles, are we going to have similar sides? Yes, these sides right here, because these are both 30 degrees, these two sides will be the same length. So this means that it is obtuse isosceles. Remember, two angles, meaning that these two sides would be the same length. So same length, when you have two sides of the same length, it's isosceles. And because of this obtuse angle, we call it obtuse. All right, let me know if you have questions. I hope that this was a good help for you. And as always, work hard, and I will see you in real life.